In this video, we're going to have a look at integrating hyperbolic functions. So if this was a simple question such as the integral of 4 over root of x squared minus 1, using the formula that I've written out on the left hand side, we can easily see that that integrates to 4 times the inverse cosh of x plus the c. However, there's this x involved that's sort of disturbing everything. So what we have to do is a preliminary step, which is we separate this into two individual fractions. So 3x over the root of x squared minus 1. Minus 4 all over the root of x squared minus 1. Now we're allowed to do this because there's a singular term on the denominator, so this is all fine. This is going to help us now because we're able to now integrate this, just like I mentioned here, to 4 times the inverse cosh of x, and we can deal with this separately. So how do we deal with this? Well, we actually have to use integration by substitution. So let's focus on doing that. We're integrating, let's first bring the denominator up to the numerator. So that's 3x over x squared minus 1 all to the power of a half, or 3x multiplied by x squared minus 1 to the power of minus a half dx. Let's change pen color because it's a different part of the question that we're doing right now. When we use substitution, we make always the inner bracket equals x squared minus 1. We can then differentiate, so du dx would be 2x here. A few different ways you can go from there. Some students like to make dx the subject of this and input that in. What I like to do is multiply both sides by dx, so du equals 2x dx, and then just replace everything so it's in terms of u. So here we want to replace 3x dx, but we have 2x dx. At this stage, we are able to multiply by a constant to make it match exactly what we want to integrate. So we have 3 halves du is equal to, well, 3 halves times 2 is 3x dx. That means that we can replace 3x dx with 3 halves du. It's getting a little bit messy, so let's write that out. 3x dx is 3 halves du, and then we have the integral of u to the power of minus a half. We can now add 1 to the power, so when you when you divide by that new power of a half, well, when you divide by any fraction, it's the same as multiplying by the reciprocal of that second fraction. So you can write this as multiplied by 2 over 1, and then that becomes 2u to the power of a half. We have that 3 halves from before, so we multiply that onto this. And 3 halves times 2 would be 3, so that becomes 3u to the power of a half, or 3 root x squared minus 1, all plus c. And that's it, that's the integral of 3x x squared minus 1 to the power of minus a half. Now that we have that, we can input that into this whole function here. So we have 3 times the square root of x squared minus 1 minus 4 times the inverse cosh of x. We're able to write it like this because I might as well show you guys. But this can be written out as 4 multiplied by 1 over root of x squared minus 1. And so when we integrate all of this, we're essentially getting 4 times the integral of all of this, which is the inverse cosh of x. So I'm right, minus 4 inverse cosh of x plus c. And that's it. That's the final answer to this whole question. Yeah, hopefully that makes sense to you. That's very bad highlighting, but yeah, be sure to like the video if this did help and subscribe. I'd appreciate it a lot. Look out for more videos on integrating hyperbolic functions. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.